Thank you very much. Thank you, Chibbe, as well, for the nice introduction. I'll help myself with my timer, since we have like 20 minutes. Welcome, everybody. Thanks for joining us. I represent Intero Integrity now, previously known as AHEC Industrial Services. Maybe you are familiar with that. We have a lot of more services like pipeline intelligent pigging with UT sensors, and also a new MFL crawler, a robot to be deployed in live gas lines, as well as specifically here in Europe, a lot of refinery special services with nitrogen and pipeline services as well. But today I would like to shortly show you our Tank Explorer robot, which is quite unique in the world in its sort, in its application, and it's certified for ATEX Zone 0. This is how it looks like. We have a robot on our booth as well. It's near the entrance of the exhibition. And it's developed specifically to scan the floor of a storage tank. It's heavy, it's not slippery in hydrocarbons, so it cannot go up the shell. It drives on the floor. It has its limitations, so I'll come back to that later. And it's developed to inspect tanks for refined product, hydrocarbons, like the diesels, the kerosenes, the gasolina, while in product is in the tank, so while in service. So you have no downtime, save hopefully a lot of money with emptying the tank, cleaning the tank, having ventilation, no people in the tank anymore for inspection, of course. So we can do the full API inspection, deliver a report for that, and also EMUA has the possibility for non-intrusive inspections in the tank, although we still focus on inspecting the floor and not the complete tank. We can do a little bit more on a video of the inside of the roof and something on the angular ring, complementary to the robot, but for us it's about the robot. This is just a sketch to explain you how we approach our projects. We like to do that turnkey as much as possible for you. It consists of 63 ultrasonic transducers. It needs to be deployed through the top manhole of the tank. So we need a 24-inch manhole on the tank. We also have a smaller version now on the booth. It can be deployed through 20-inch manhole. And it has quite a high accuracy. Of course, we can report all the defects which we can detect on the top side of the bottom plates, but also on the soil side of the bottom plates. We can locate the position of the defect on your numbered plates, as well as the sizing of the defect. With a probability of 90% of detection, we can report defects of 10 by 10 millimeters. And the accuracy of the plate thickness we are measuring with ultrasonics is 0.25 millimeters. So we can measure the remaining plate thickness with an accuracy of 0.25 millimeters. For that we need a proper navigation system. This is not easy. We place temporary transmitters along the shell of the tank, and so together with the robot we can have the triangle navigation. Besides that, we have cameras and a light on the tank, looking down at the plate, looking forward. We can even mount a 360 camera, a pen tilt camera on the robot. It's only useful if we have a vision in the product, of course. If we don't have vision, we also have a sonar system in the tank, not to collapse with any internals in the tank. And then besides that, because we also have a very sensitive pressure switch, on the robot, we can also report the settlement of the bottom plates. So before we do I have the thing here? Yeah. Before we deploy the robot in the tank, we make a plan together with you, an inspection plan, to determine where we want to inspect. In the next slide, I will show you where the physical limits are, of course. We will make a plan scanning. Most of the customers ask for 100% scanning of the floor. To us, it does not always make sense. It's maybe not necessary. If you have acoustic emission reports, you maybe want to focus on specific areas of the tank. Maybe it's not possible, but at least it's more cost efficient if we do like 50% of the tank, whatever. But we can do full scanning of the tank. In theory, we can do an extra round on the annular circle of the tank. And then we can do some extra determinations of the bottom settlement of the plates. Right? Yep. Well, some physical limitations like internals on the bottom. Heating coils, of course, it's a no-go. Almost every tank has a sump line and a sump pit, so we have to avoid that as well. Because what I didn't mention is you can see it has a cable, an umbilical, quite large one. It's purged with nitrogen, so when we deploy the robot through the top manhole, maybe through the vapor zone above the product, so that's where we have the ATEX Zone 0 for. To have a safe deployment, the robot is completely dead, switched off. We deploy it through the vapor zone, the umbilical hose, where all the cables for electrical power, data transition are through the umbilical. It's purged with nitrogen. We deploy it to the bottom, and when it senses several meters of liquid on top of the robot, then we can switch the robot on. There's no oxygen. It's in the product, and it's safe. So there's an umbilical, so we have to avoid that it gets stuck somewhere, because that's what nobody wants. So we be careful with roof legs, for example, and well, the heating coils and the sump pit, as I mentioned. So we have to take care of that. And another limitation is temperature. We're upgrading the robot now to be to make it possible to inspect above 40 degrees Celsius, but that's for now, it's the limit because of the sensitive electronics and the ultrasonic transducers. And cleanliness of the tank, that's an issue as well. So that's one of the reasons why for now we are avoiding inspection in crude oil tanks, because of all the sludge and the wax on the tank floor. That's still a challenge. We now have some solutions to spray away some loose debris on the floor. If it's like maximum a few centimeters, it's loose debris, then we suck clean product from 2-3 meters behind of the robot, and we spray it around through nozzles in front of the transducers. We have a rubber skirt around the transducers as well to push away the loose debris. So that works fine, but the cleaner the tank floor is, the better measurement results we have on the report. So we have it Zone 0 certified by DECRA. You cannot really read the document, you understand, of course. Besides the robot, we also had a look at our working procedures. They are also considered safe for deploying in Zone 0, because we feel it's not only about having a stamp on your equipment, but it's also about how you deal with the robot and how are your working procedures to deploy in a hydrocarbon in a safe way. Besides deployment in hydrocarbons, actually we also use the robot very often in emergency water tanks, which cannot be taken out of production. They have a lot of corrosion on the floor as well. So that's a nice usage there as well. That's where we use the non-ATEX robot for. So I'm quite nice with my time. Two things I'm going to show you, a use case, and first something about how we like to report. We like to come close to the MFL floor scans you are used to. This is only the graphical presentation of the report. I have one more slide of a C-scan, UTC scan. Of course, you also get the Excel lists with all the defects and the sizing and the location, etc. But this is just to give you an impression. We number the plates as you are used to, and then we show you where we have driven with the robot. So the white spots is where we missed it for inspection, and the large line is where the sump line was. You understand that, I think. Then UT can also easily detect laminations inside the steel plate, carbon laminations, which are included. Well, here in this specific tank, it was only in plate 5, so that was a bad plate coming out of the milling factory at that time when the tank was built. Now here we are showing the defects we detected on the product side of the tank. We have small defects and larger defects. We play with the colors. We have different colors depending on the remaining plate thickness. Okay, here you see at least that it's generally spread all over the tank floor. This is maybe of more interest. These are the defects we detected on the soil side of the tank. And here you see that it's mostly only existing around the angular ring where the water comes under the tank. And here you also see the deepest defect we detected here, the yellow one with the 4.3 millimeters remaining plate thickness. And then these are all the defects, and this is without defectors. So well, this is just the graph, but this is at least what we can detect in a tank, in a live tank, in product. So one recent use case study we did executed in the Mediterranean area of Europe. 2 tanks actually. Customer requested us to inspect a gasoline tank of 45 meters diameter and a large diesel tank, 82 meters. So it's quite large tank. Our umbilical hose is like 100 meters. So we had to find a solution to deal with that because the main entry of the external floating roof was in the center of the tank. So we needed 40 meters to go there and then going down and 40 meters to go to the shell. So this is just an impression of the project plan we made for this inspection. But you maybe see here, we projected a scaffold to bring the hose reel with the umbilical to the top of the tank. So we had just enough length of the umbilical, so we could inspect the complete tank. Besides this part here, yeah, the yellow parts where the inlets are, and a swivel line, we could not inspect there. But so we inspected like 85% of the tank floor here. There were also a lot of roof legs which were removed here. It was as well quite a tight schedule. We inspected the 2 tanks within 2 weeks. We always request a mobile crane to deploy our robot in the tank. We can leave it for a few days in the tank, inside the tank, if customer agrees, and then after a few days of inspection, we of course retract it from the tank. Safety is always a big issue, as you understand, because this is something else, something new again. But we have inspected quite a large number of tanks in the meantime, in several products, also in polyol, in amine, in what else do we have? In some light crude, we tried that as well, in loop oil. But we're focusing on the refined products. Let me see. Well, these are just some photos of our crew in the inspection van. We tried to place it outside the bund wall on a safe area. Well, here you see the scaffold and yeah, the guys. A proper project preparation, of course, lots of discussions with the customer. But if everything goes well and the tank bottom is kind of clean, then we have a good can do a good inspection within a week, mostly. Yeah. Well, and this is some other parts of the report. The defects we detected on this tank, and an impression of the C-scans. We make C-scans in the report for the most severe defects we detected. Here, the deepest defect had a remaining thickness of 5 millimeter, where the nominal plate thickness was 8 millimeters. Well, you can read that yourself. As an extra, the customer requested us to do an extreme value analysis. I don't know if you're familiar with that, but mostly used on API inspections. It's a statistical approach of the defects we discovered, we reported. Well, so maybe any questions from the audience? Or it was quite clear? Can also be the case. Yes? Yeah. I can speak here.
Yeah, David Lamont with Square Robot. Do you do an inspection of the corner weld in the base of the wall?
Yeah. Good question. Indeed, the robot can come close to the shell, of course, but the first ultrasonic transducer is like 1 inch from the shell, so it cannot inspect the inside corner weld with the robot. So we have another solution to do this inspection from the outside. It has an overlap with the robots. It can inspect with phased array, 2 phased array UT transmitters from the outside. We can inspect the inside corner weld. Also, we can detect cracks on the corner weld, so that's a big plus. And 100 millimeters inside the tank of the angular plate. So yeah, that's not with the robot, separate solution, because a lot of customers like yourself ask for the inside corner weld inspection. Yeah. Anybody? Then I'd like to thank you for your attention, and please visit our booth. It's near the entrance of the exhibition. Thanks.